Hello everyone. Today we are going to discuss some more examples on this chapter, lines and angles. So here is an example given to us, as you can see on the screen. Example number 4. This is right from your textbook. So here the question says in figure, so this is the figure given to us. If PQ is parallel to RS, this line PQ and RS, they are parallel to each other. Angle MXQ is equal to 135 degree. As you can see, angle MXQ, this angle is 135 degree. And angle MYR is equal to 40 degree. So angle MYR, this angle is 40 degree. This is given to us. Now what we need to find in this question is that we need to find angle XMY. Clear? So first of all, in the solution we'll write down what is given to us. Directly from the question itself we can write it down. Next we need to do some construction. As you can see here, I have drawn another line AB and I have given here dotted line. Why this dotted line is given? In geometry, whenever we do any kind of construction, it is shown by a dotted line. Clear? So here also we have drawn a line AB which is parallel to PQ. We have drawn in such a way that it is parallel to PQ and it is passing through the point M, exactly through the middle of the point M. Now, as we already know that AB is parallel to PQ from this construction, and from the question we know that PQ is equal to RS. So can we say that AB is parallel to RS? Yes, we can. Since we already got a theorem 6.6 in our earlier class, in the previous class we got that lines parallel to the same line are parallel to each other. Understood? So the lines, which lines? The lines PQ and the line RS. If you consider these two lines, so you can see here AB is parallel to PQ. AB is parallel to this line. Similarly, PQ is parallel to RS. Clear? So both are parallel to PQ. That means these two are also parallel. This is what is said by this theorem. Clear? Now, angle QXM. Where is angle QXM? This angle QXM. This is given to us. Plus angle XMB. It will be equal to 180 degree. We have also learned one theorem that if two lines are parallel, then the interior angles on the same side of the transversal, if we consider XM as a transversal, the angles on the same side of the transversal, the interior angles, they will be supplementary. Their sum will be supplementary. So interior angles on the same side of the transversal are supplementary. We have got a theorem. So then we have to substitute now the value of QXM, which is given to us. QXM is nothing but it is MXQ, same thing. Understood? We can add angle MXQ as angle QXM also. It is the same thing. So we have substituted the value 135 degree. Now we don't know the value of XMB. We have to find it out. So XMB value, we can, after solving, we can see that it will be 45 degree. So we got this angle XMB. This angle we got it. Clear? Now, next what is required? Now angle BMY. Where is angle BMY? This angle BMY. This angle. This angle will be equal to this angle. Why? Because since AB is parallel to RS and if MY is a transversal, then angle BMY and angle MYR are what? Alternate interior angles. So they will be equal. So angle BMY will also be equal to 40 degree. Clear? Now we will just substitute the values. So if you see carefully, angle XMY is nothing but it is the summation of two angles, angle XMB and angle BMY. So angle XMB value we got how much? 45 degree, and angle BMY value we got 40 degree. Now if we add them, we will get 85 degree. So our required angle, that is angle XMY, is equal to 85 degree. So I hope this is clear to you now, how to find out the value of angle XMY. Now let us see the next example. Example number 5. Now what the example number 5 says, if a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. Now let me explain it to you. If a transversal intersects two lines, so here we have drawn two lines PQ and RS. Now it is not mentioned that they are parallel. We have to show that they are parallel. And they are intersected by a transversal AD at 2 points B and C. Clear? Such that the bisectors of a pair of corresponding angles. So which will be the corresponding angle? Angle ABQ and angle BCS. These are the corresponding angles and they are being bisected by the angle bisectors. So which will be the angle bisectors here? BE and CG. Now what is an angle bisector? An angle bisector, it divides an angle into two equal halves. So this BE has divided this angle ABQ into two equal halves, that is ABE equal to angle EBQ. Similarly here CG is an angle bisector which has divided this angle BCS into two equal halves, that is angle BCG and angle GCS. So both are equal. Clear? Now we have to prove that PQ is parallel to RS. This is what we have to find in this problem. So let us prove it. So first of all, what we have taken here is that angle ABE. So carefully if you watch angle ABE, this angle will be half of angle ABQ. Yes, obviously, because BE is a angle bisector. So it has divided angle ABE, this angle, and EBQ into two equal halves. That means this angle, if we consider angle ABE, this will be only half of the total angle. So that's what we have written. It is half of the total angle, and the total angle is angle ABQ. This angle ABQ. Similarly, in the next case, you can see angle BCG. Angle BCG. This is only half of the total angle, that is BCS. Clear? Since CG is an angle bisector. So we have marked it equation 1 and equation 2. Now, if you see carefully, BE and CG are parallel. This is given to us. BE and CG, they are parallel, and AD is already a transversal. So in that case, what we can say is that angle ABE is equal to angle BCG. Clear? Because then in that case this and this angle will be corresponding angles. By the corresponding angles axiom, we can say that angle ABE will be equal to angle BCG. Clear? And we'll mark that as equation 3. Now what will you do is that in equation 3 we will substitute the value of ABE and we'll substitute the value of BCG. That is nothing but the value of ABE is half of angle ABQ and BCG is half of angle BCS. So this half will get cancelled out. So we will be left with angle ABQ is equal to angle BCS. So angle ABQ will be equal to angle BCS. But these are what? These are corresponding angles. Clear? So since they are corresponding angles, so by the converse of the corresponding angles axiom, we can say that PQ is parallel to RS. So that is what we need to prove in this example. So I hope this is clear to you. Now let us see the next example. Example number 6. So in example number 6 it is given in figure AB is parallel to CD. So you can see AB is parallel to CD, this line. And again CD is parallel to EF. Okay. Also it is given that this EA is perpendicular on AB. That means this angle EAB will be equal to 90 degree. This is clear. Now angle BEF is equal to 55 degree. Angle BEF is 55 degree. This is given to us. Now we need to find out the value of this X, Y and Z. This is our main task to do in this example. So let us begin. Now, if you see carefully in the figure, angle y and angle y and 55 degree will be equal to 180 degree. Why? Let me give you the reason. Now, as it is given that CD is parallel to EF and this DE is the transversal, clear? Then this angle y and this 55 degree are on the same side of the transversal. Then if we remember carefully, there is a theorem which states that the interior angles, these are interior angles lying between the lines CD and EF, parallel lines. So the interior angles on the same side of the transversal are supplementary. So that's why we written angle y plus 55 degree is equal to 180 degree. From there we can get y equals to 125 degree. Now if we consider AB and CD, these two are also parallel lines. So here if you see angle X and angle Y, what kind of angles are they? Yes, they are corresponding angles. So this angle Y and angle X and angle Y will be equal by the corresponding angles axiom. So value of angle X also will be 125 degree. Now in the question it is given that AB is parallel to CD and CD is parallel to EF. So can we say AB is parallel to EF? Yes, of course we can. There is a theorem. Lines parallel to the same lines are parallel to each other. From there we can say that AB is parallel to EF. Now we need to find out the value of this Z. So how to find it out? Again we will be using the use of parallel lines. We can see that AB, we already got now, AB is parallel to EF. So we can use this, and if we consider this BE as the transversal, then we can say that this angle FEA and angle EAB, sorry, we will not consider this BE as the transversal, we will consider AE as the transversal now. If we consider AE as the transversal, then angle FEA and angle BAE, they will be supplementary because they are lying on the same side of the transversal. This whole angle and this angle, they are lying on the same side of the transversal AE. Clear? So they will become, they are also interior angles because they are lying in between AB and EF, in between it. So by the theorem, that is interior angles on the same side of the transversal are supplementary, we can say that angle FEA plus angle EAB will be equal to 180 degree. Now angle EAB, already I said that since EA is perpendicular on AB, so this angle EAB will be equal to 90 degree. So we have written 90 degree, and FEA is divided into two angles, angle Z and this angle BEF. So we can write it as Z plus 55 degree. From there we can calculate out the value of Z, that will be equal to 35 degree. So in this way we can find out the values of angle X, Y and Z in this question. So I hope in today's video you all have understood the three examples, example 4, 5 and 6. In the next class we will carry out with further more examples in this chapter. So till then, thank you and have a nice day.